of services are running on this machine. So if you want to find the users, I typically look at root, and then I look and scroll all the way to the bottom to see what's been installed besides what's on this machine. So in here, we can see some things like SSH, which is important. We know, okay, this has the capability of running SSH. Maybe it has an SSH service. Maybe it has a SQL service here with the MySQL, OpenVPN. So it's a little bit of information gathering. If we were to land on a machine, for example, and we're a low-level user with no privileges, we could start to look at who are the other users on the computer. Why are they important? How can we get a hold of them? Where are their files located? What kind of services are running on this machine? This is all part of the information gathering stage of ethical hacking, and this file leads to a lot of clues for us. Now, clearing the screen, let's say I want to view the shadow file. The shadow file is the file that contains the password hashes for this machine. I'm going to go ahead and try to type in cat Etsy shadow. Permission denied. Okay, maybe I need to use sudo. Let's try it here, enter our password. Oh, John is not in the sudoers file. This is also called the sudoers file, and you can also call sudo sudo. Depends on your nomenclature and how you pronounce it. I'm a sudo person. So from here, I'm going to go ahead and Control L. We're going to switch user back into Kali, and we're going to take a look at some stuff. So if I go switch user, Kali, it's going to ask me for the password. We're going to enter our password in. And first thing, I want to show you the shadow file before we move on to the sudoers file. So if we go sudo cat Etsy shadow, I think this is important to see. You can come in here and remember how I said with a hash that this is set here. So our root password has not been set. There's no hash in here. And this is security best practice. We don't really want to have a root password unless we absolutely need to. In this instance, we might just want to have certain users that can elevate into root, and then if logging is enabled, we can then see from our logs who accessed that root account at what time. You really don't want to have a root password where anybody can just log in with a known password, because then that eliminates some accountability. So best practice would say, hey, if we have a Linux machine, you get all regular user accounts, and then if you want to run something as an elevated privilege, you're going to do that with your account and then use sudo for that. But looking down here, we can see the hashes for this computer. Okay, and what's interesting actually is Callie and John have the same password, but they have different hashes. And that is sort of unique. If you saw this in a Windows machine, if the password was the same on the local machine, you would see the exact same hash, and that is a clear indicator that password reuse is in play, but here it's not. So the hashing algorithm that's being used is a little bit different, and it's generating different hashes even though the password is the same. Regardless, the password for both of these accounts is password, and that's very weak and can easily be cracked, as we'll find out later on. Okay, now onto the sudoers file. What we're going to do is we're going to do a sudo cat, and we're going to look at Etsy sudoers, just like that. And I might have typed that a little fast, so I'm going to go ahead and scroll back up for a second. Sudo cat Etsy sudoers. Okay, just like that. It should auto tab complete. And from there, we're going to come in here and we're going to look at who has what privileges. Well, if you see allow members of a group sudo to execute any command, and you see %sudo, so it's calling sudo from somewhere else. Sometimes we can just include users in here. We could say, hey, the user Callie, I want to do these things. Instead, this is saying, hey, anybody a part of this group, I want to be able to do whatever they want. They can execute any commands like they were the root user, essentially. So with that, what we're going to do is we're going to take a look at who is in that %sudo group. And we can do that by using the grep command. So we can say grep, and we're going to get really familiar with grep in the bash scripting video. But basically think of grep as pulling out a specific string or element out of a file or some contents that you want to see. It's a great way to narrow down specifics and pull down only the information that you want, and we're going to get really familiar with it here in a couple of videos. So we're going to say grep, and then we're going to say sudo, just like this. And we're going to do that from Etsy group. Okay, and it says who has the sudo privilege. Here, all we see is Callie. So our user has sudo privilege. If we wanted to give privileges to John, we'd have to add John to the sudo group in the etc group. Or we could add John specifically to the sudoers file and give him specific permissions as well. And as we move on in the course and we get into privilege escalation, and if you ever go into more of the privilege escalation courses that we have, you'll see that we look at sudo privileges immediately when we get onto a machine by doing something like sudo-l, and we'll take a look at those and say, okay, what commands can I run? And in this instance, we could see, okay, all commands can be run here. But sometimes that's not the case. Sometimes we can only run one specific command, or maybe John, for example, we want John to be able to run Python because John's a developer. So John can run Python with sudo privileges, but cannot run anything else. So something to think about. Depending on the individual and who we want to give permissions to on that machine, they might not have privileges to access everything as sudo. They can actually be limited in what they can run as well. So that is it for this video. I'm going to go ahead and catch you in the next one. Now we're going to touch on networking commands that are relevant to penetration testing and relevant to this course. So the first thing that we're going to do is we're going to use the IP command, and that is IPA. IPA lists all is the way I like to think about it. And you can see here that we have a loopback address and we have our ETH0. This is our Ethernet address. And you can see that we have an IP address here, IPv4, of 192.168.138.140. We are on a /24 subnet. And here is our broadcast address here. We can also see our IPv6 here, which is nice. And we can see our MAC address here. So we can also look at this through the ifconfig command. And that will show us the same things. Here's Ethernet 0. Here is the loopback. All the same information here. ifconfig is the old school way of doing it. IPA is the newer way of doing it. IPA is nice and colorful. If I'm being honest, I still use ifconfig because I like the old school way of doing things. But IPA is the new way of doing things, and in some instances, ifconfig requires sudo to even run or may no longer be on a machine. But in some instances, IP is not on a machine. Depending on what type of machine you're on and what you access, you may need either one of these, so it's great to show you both. Now, while the IPA does all, IF only shows the Ethernet connection, so the hardwired connections. If we want to see wireless connections, we need to do IWconfig. And in this instance, you're going to see down here that we have no wireless connections right now. When we get into wireless hacking, we'll see that we have connections established and we'll use the IWconfig command. But just know for now that it's for wireless, and if you ever need to use it, that's what it's for. Let's clear our screen, and the next thing I want to cover is the IPN, and N stands for neighbor. The alternative to this is the ARP-A. Okay, what is ARP? If you do not know what ARP is, that is the Address Resolution Protocol. This comes from your networking. If you are not familiar with networking, then you may need to go study up on a little bit of this. Now, ARP says what IP address is associated with what MAC address. And what happens is a broadcast message goes out when we are trying to identify an IP address and a MAC address. So broadcast goes out and it says, who has this IP address? And whoever has the IP address will come back and it'll say, hey, that's me. I have that IP address and here is my MAC address. So now you can associate my MAC address with this IP address. And it is a way to identify these two items together and link them up. So again, in this instance, we can use the IP command or the old ARP command. Now the IP command is a little bit prettier and a little bit more colorful and I think easier to read in my opinion, but either will work in this situation. Another IP command that we're going to want to run and know is the IPR command. Now R stands for route. You could also type in route and you'll get similar feedback here. So what we're looking at is what is called a routing table. We want to know where our traffic is routing. And here you can see on either one of these that we're routing through 192.168.138.0. We have an open gateway. We can see the gateway here is 138.2. We can see our mask here, and we can find all that information out up here as well. So it's important to know the routing and what's going on, especially if you are in a network, for example, where you might have multiple routes. Say if we come in and we say, oh, IPA, okay, we're on the 192.168.138 network, but we just try to connect to only the machines on this network. We see a /24. We think, okay, well, I know a /24 has 255 potential IP addresses, and I'm going to go ahead and just stick to scanning that subnet and looking for those IPs on that subnet. Well, if you looked at the routing table, you might actually see that there's a 137 in here, 136, or maybe a 10 IP address or something different than what you have here. Maybe you have the ability to talk to other networks even though you're on this 1/24 network. Very important to look at the routing table. It's also important because in real life pen tests, we have been on a quote unquote segmented network. And in reality, it really wasn't a segmented network. There just wasn't a route to that network. So they said that we were isolated and we couldn't access anything. And all we had to do was say, okay, we're going to go add that network to our routing table. And what do you know? We were able to scan and connect to the network. So being able to know your routing table, being able to understand what a route is and how to add routes, how to remove routes can become important as well. These are things that you should already know from general networking. I'm showing you the commands here for basic routing and how to display the routing tables. If you need further information on routing tables, you should go look that up and research that before continuing on with the ethical hacking course. Okay, last command I want to get through. That is the ping command. So I'm going to do an ifconfig again. And in this instance, I'm just going to ping 192.168.138. And I believe earlier I saw a .2 was my gateway. So I'm going to go ahead and just hit enter. That should talk back to me, and it does. Now, if you are a Windows user and you've ever used ping before, it will only send 4 packets out. So it'll check 4 times. As you can see here, we are getting more than 4 packets sent. We are sending indefinitely. And I'm going to go ahead and just hit Control-C and stop that. We are definitely seeing that we're getting responses back. Now, there is a way to limit the amount that we send and the amount of traffic that we're sending. But basically what we're doing with the ping command is we're saying, hey, are you there? Are you alive? Can you respond to me and let me know you're there? So I asked the machine at this IP address to respond and tell me, yes, I am here. Now, this is called ICMP traffic. Not all machines permit ICMP traffic. Just because we ping a machine and it does not respond does not mean that it's not online. Okay? There are machines that have ICMP disabled and will not respond to ping requests. But ping is a quick way to see if a machine is online, and typically by default, ping or ICMP is enabled on most machines. Just as a further example, we can ping a machine that we do not believe to be alive. So I'm going to change this to a 3. I don't think there's a 3 on my network. And you're going to see it's going to try to send data, and it's just going to get stuck here and say host unreachable. Now again, that could potentially mean that that host is not there, or it could potentially mean that the host has ICMP disabled. But we're going to be using ping sweeping to identify a host in our network. And we'll do that here in just a couple of videos, but I wanted you to get familiar with the ping command if you weren't familiar already. Now, there are some commands in this video that we did not talk about. For example, the netstat command. Now, the netstat command is used to identify what open ports and services are there. We'll take a look at that more later on, but just know that that command exists and that we're going to do due diligence on that command later. So any of you that are watching that have a networking background or are like, hey, you didn't show netstat, that's so important, you're correct. It's coming later on in the course. So that's it for this video. We're going to go ahead and move on to the next one. Let's now talk about viewing, creating, and editing files. And we've done a little bit of this in the course already. You've seen me do something like echo hello, and remember that prints out to the screen. And we could just echo that again, like a hello, and put that into a file. And you've seen me do that. We'll just call this one hey.txt. And if we ls, we should see hey.txt right here. If we do a cat hey.txt, we should print out to the screen, hello. All these should be pretty familiar to you. So let's build upon this. Let's talk about how we can append to this and overwrite these files in different ways that we can actually create and edit files. So I'm going to clear the screen here. Now, what if I wanted to add to this file, and I'm just tabbing up, by the way. What if I want to say hello again? So I want to say echo hello again into this hey.txt file that already exists. What do we think is going to happen here? So I'm going to go ahead and hit enter, and then I'm going to cat out the hey.txt. Well, now it says hello again. It used to say hello. Well, that is because when we use one greater than symbol like this, what's going to happen is that overwrites the file. So if we tab up, and if we go over and we just write hey again, just for fun, and let's add a second one of these. So now there should be two of these greater than symbols. We hit enter, we cat out hey.txt, and now you can see it says hello again and hello again. Why do we care? Why are we doing this? Well, when we are using scripting, for example, and we want to loop through a bunch of information and we want to add that information to a file, we might use something like this, where if we're gathering, say, IP addresses, this is foreshadowing, by the way, say we're gathering IP addresses and we are wanting to put them all in a file, we're going to need to use something like a double greater than in order to not overwrite the file with one IP address. We want to list all the IP addresses in the file. So you're going to see that when we get into the bash scripting of this section. Let's clear our screen. Another way that we can make a new file is just to say touch new file.txt. And if we ls, you can see that new file.txt is here. We can cat out new file.txt, and nothing is going to be in there because we didn't tell it to do anything. We just said touch, which creates a file. So we can use a different type of editor to try and edit this and save the file. Now, there are a few editors that we can use within our terminal. So we can use something called Nano, which is my personal favorite. You may hear other people talk about Vi and Vim. You may hear lots of jokes about quitting Vim and how it's impossible to quit Vim. And for that reason, honestly, because of the complications and because I like simplicity, I just use Nano. So we can Nano new file. And in here, you can type whatever you want. I'm going to literally say, I can type whatever I want in here. And now I'm going to hit Control X. And throughout this course, you're going to actually see me use Nano quite a bit. And we're going to use it for updating files and shellcode. And it's beneficial if we log into a machine remotely, for example, and we won't have the ability to have a graphical user interface type notepad, which I'm going to show you here in a second. We might not have the luxury of having something like that. We might have to use Nano or Vim or an in-terminal text editor. So we're going to go ahead and hit Control X here. I'm going to hit Y, which is going to say, yes, I want to save this file. And then I'm going to hit enter. And now if I cat out new file.txt, you can see it says I can type whatever I want in here. Lastly, we're going to look at a graphical notepad. So we're going to use mousepad. We can type in mousepad. And we can just say new file.txt, just like we created. And in here, you can see that it says I can type whatever I want in here, and that's true. I can also modify. It's just like a notepad if you had on Windows machine, or if you've used LeafPad or any sort of notepad type material. This one's just called mousepad. So we can Control S and save, and then just exit out. If we cat out our new file again, you can see I can also modify. Now, throughout this course, you might see me use a tool called gedit. It is not installed on this machine yet, though we are making updates to the course, we will be using gedit. Anytime you see me use gedit, feel free to use mousepad instead of gedit. It's become deprecated. Offensive security got rid of it in Kali Linux, and now if you go hit gedit, it'll say it's not found, but you can install it. We're not going to do that right now. But when we install tools in a upcoming video, you will be able to install that with one of the tools that we're running. So anyway, just note that we're going to be using mousepad instead of gedit because it's the new and latest and greatest. One last thing, with Nano or any of these tools, you can make a brand new file. So you can say like brand new file.txt, and then you can type whatever in here and Control X, hit Y, hit enter, and then you can cat out brand new file, and guess what? It's there. So the file doesn't have to be existing to use Nano or existing to use mousepad. You can create new files with these commands as well. So that is it for this video. I'm going to go ahead and catch you in the next one. Another topic we need to talk about is starting and stopping services. We may have a service like a web server or SSH or maybe SQL or some sort of database that we need to start while we're already running Kali, or we might want to start a service on boot every single time that our computer loads. If you've ever used Windows, this is similar to installing a program and then having that boot up on launch. It's kind of the same thing here. If we're installing something, we want that service to start on launch, we have to tell our machine to do that. So we're going to look at how to start a service and how to have a service start on launch. So the first service that we're going to look at is the Apache service. And this is what I used to use when I first started out as an ethical hacker. And the reason is that we can spin up our own web server fairly easily and host malicious data or files or things that we might want to access or might want somebody else to access. So before we run that command, I do want to do a proof of concept. So let's do an ifconfig, and we're going to grab our IP address here. I'm going to copy this, and then I want to open up Firefox. From within Firefox, I'm going to go ahead and try to navigate to that IP address. And you're going to see that it says it's unable to connect. This is exactly what we expected. So now what we're going to do is we're going to come in here and we're going to say sudo service Apache2 start. We hit enter. It's going to ask for our sudo password. And then we have no confirmation of anything. So let's go ahead and come in back into the browser. And we're going to refresh. And let's take away the HTTPS. And now you can see that this is here on port 80. So we are actually on HTTP, not HTTPS. And we have an Apache server running now. Now let's say we wanted to stop this service. We can go in here and say sudo service Apache2 stop. And before we do that, I want to show you something. So if we come back into the Apache2, I'm going to make this a little bit bigger. You can see that our files are located in the var www HTML folder. And what that is, if we come to our home folder here, and we just go to file system, and we scroll down and go to var, and then we go to www HTML. All I'm doing is going to the same location here. Why I'm doing this is where if I wanted to host like a picture or a file or malware, I could put that in here. This index.html is the same index page that's loaded here. Like if I open that, that's literally the same page that's being hosted. You're seeing it here from a file format, but now if I go back, you can see I'm hosting it at this IP address. So if I wanted to host something malicious, I could do that. Now, in order to stop the service, all we have to do is say stop, hit enter, then we come back and we refresh this page. You can see that we're now again unable to connect. Now, I did mention in the beginning of this video that this was my favorite way to host malicious stuff or just host files for whatever purpose. Now that has changed. I now use Python to do this. So we can create a file. Let's go ahead and just say echo hello, and we're going to do hello.txt. So if we ls, we can see that we've got a bunch of stuff in here. Hello.txt being one of them. So what I'm going to do is I'm going to spin up a web server on the fly with Python. So I'm going to say Python 3-m http.server, and then I'm going to give it port 80. Now, what we're saying is we want to run the module HTTP server, and we're going to run port 80 here. You can put whatever port you want. And you can see now it says, hey, it's hosting up HTTP on port 80. And what's going to happen is any file within the directory that I'm in is going to now be hosted. So you can see that I'm hosting all this stuff here. Pretty awesome. It's a quick way to host up a web server without having to start and stop services. And you can, on the fly from within a folder, just start a web server. So I think this is the cooler and better way to do it. So I wanted to show you how to start a service, but also that Python has some robust capabilities as well. If you follow into the Python section, we'll cover how to run an FTP server as well, which is also fun stuff. So I'm going to hit Control-C, which is going to, again, shut down this server. If I come here and refresh, you'll see that it's now shut down. And we can go ahead and talk about one more thing before we go. So let's say that we wanted a service to start when we started our machine. Well, for that, we're going to use the systemctl command, systemctl. And we can say enable. And if we wanted to, for example, enable SSH, we can come in here and just enable SSH. And we just hit enter on this. And now you can see that it's enabled. So when we restart the computer, SSH will always be enabled for us. Now I'm going to disable that. This isn't like security best practice. And now you can see that we have disabled it and we're good to go. So if you ever have a service that you want to run, you just need to figure out the name of the service and enable that. And there may be times that you want things to run. Like historically, I have ran SSH with it enabled, or I used to run the Apache 2 server, so I didn't have to spin it up every time. I just had a place to go immediately host that. But your mileage may vary depending on what it is you want to run, but knowing these commands is important in case you need to start or stop a service, maybe restart a service. Same thing with enabling a service at boot up or disabling a service at boot up. So that's it for this video. I'll go ahead and see you over in the next one. Now let's talk about installing and updating tools. So the first thing that we're going to do from our command line is we're going to look at how we would update our current machine. So just like other operating systems, Linux machines require updates as well, and patching can be best practice. So in order to update and upgrade our machine, we're going to use the sudo command, and we're going to say apt, and then we're going to say update and upgrade, just like that. So make sure you use two ampersand symbols here. We're going to do two commands. We're going to say, first, I want you to update. Second, I want you to upgrade. Well, why are we doing this? Why are we running two commands in the first place? Well, what we do when we actually install items on our Kali machine, we are going out to what are called repositories, and we're looking through packages. And the update command is going out to the known repositories, and it is updating those repositories. And then it's going to look at those repositories and say, okay, what needs upgraded here? So what tools have upgrades or updates available for them that we need? So if we run this command, you're going to see that it's going to go through these repositories. You can see it going through these Kali rolling and release, AMD64 packages and contents, etc., etc. It'll take some time. As it goes through and it updates these repositories, it's going to find what programs we need, and it'll provide it in a list. Now, what you can see is it's asking us, are you root? So this is a lesson here. Sometimes we have to be the root user. We can't be just a sudo user to run commands. So what we're going to do in this instance is we're going to sudo switch user into root. Now we're root, and we're going to run that command again. We're going to say apt update and apt upgrade. Okay, and it's going to run through this, and then it should provide us with a list of what we're going to install, which if we scroll back up to the top, you can see that it says, hey, these packages were automatically installed and no longer required. And it says we can use the apt auto remove command to do that. It's saying here are the brand new packages that need to be installed. And then here are the packages that are going to be upgraded. So these are already installed, such as like Apache 2 has some updates that are required. And it's going to go through and install all of these. Now, when you scroll down to the bottom, it's going to say you need 801 megabytes, and yours might be different depending on when you watch this video. It's going to say, do you want to continue this operation? In this instance, I'm going to say no. And the reason that I'm going to say no is because updating on Kali Linux can break things. You should always have almost 2 copies of your Linux, right? You should take a backup copy before you ever make an update. And there are some limitations on being able to make backups, depending on if you're using VMware or VirtualBox, and we're not going to get into that right now, but just know that tools can easily get broken by pushing updates. And we'll talk about a tool that you can use that is up to date and kind of makes your Kali the latest and greatest without breaking anything. Even the current version of Kali right now, 2022.2, not all the tools work out of the box as the way that they should. We'll talk about that in just a little bit. So let's say that you wanted to install a tool, and we're just going to go grab one as an example. So let's say that there was a tool you wanted to install, like this cron daemon common. I'm just going to copy that. You could come in here and you could say apt install cron daemon common like this. Hit enter and it's going to say, oh, you want to install this? Just hit yes and it will install. And it will also upgrade this cron package here. I'm not going to do that, but just know that you can also install applications as a one-time thing if they're a part of the repository that you have. We're not going to get into updating repositories and adding manual repositories. We don't need to know that at this point in our Linux careers. We just need to understand that we're going out to a repository and we can download those items or packages based on what is in the repository. So updating the repository is always good, and then we check for upgrades available to our packages. In this instance, we're not going to do any updating or upgrading, but there may be a time where we need to install a specific tool, or we go out to the web and we have to grab a tool and it says, hey, run this apt install command. This is what it's going to be doing. This is how we would install something if we need to. Now, the next thing that we're going to look at is we're going to look at the git command. And Git is a tool that runs with GitHub. I'm going to open up a new Firefox, and I'm going to make this a little bit bigger. We're going to go to GitHub. Actually, let's just go to Google. We're going to go to Google. And a lot of times in our ethical hacking careers, we're going to be searching for tools. We're going to come out here and we're going to say, oh, I really want to find a tool maybe that does brute force Office 365. And then I might say something like GitHub, and you can see it's already starting to fill out. And we might go find something like, okay, there's this daft hack tool. We might click on that. And we come in here and it might tell you how to install this. Well, this is PowerShell, so that's not a great example. We might come into here and we might say, okay, here's one how to install. So you go through and it'll say, here's the usage on how to use this. And sometimes they'll give you installation instructions, but a lot of times all you will need to do is you'll need to come in here and just download the code to install the file. So I'm going to show you a tool that we're going to install and run. We go to Google and we search for pimp my Kali, just like that. You're going to see that we can click in here and this tool is available to us to download. Now, one way to look at a tool and see if it has any relevancy on GitHub is to look up at the number of stars that it has and the forks that it has. Anything with like 700 stars like this is pretty reputable, and you also should look at when it was last updated. You can see that this was last updated last month. Now, full disclosure, DeWalt actually works for TCM Security and is a fantastic person. If you never got to interact with DeWalt, he is somebody that is awesome and a great resource. He built this out because there were so many issues with Kali Linux, and the tools that were coming freshly installed, like in 2022.2, don't always work in the way that we intend them to work. So a lot of tools are broken, some things need downgraded, and there's a lot of options in here that can tell you, hey, here's what we can fix. Like we can fix different missing issues that are going on, or we can fix Golang or fix Impacket. And you don't have to worry about what any of that means right now until we get into pen testing. But this is something that we actually do install and run when we build out our lab machines, or we build out our machines for even hacking on clients. This is such a well done tool. And he tells you in here how to install it. He says, hey, get clone right here off of this address. We can also come up here and we can go to the code and we can just copy. We say copy pimp my Kali right here. And then we'll come in and we can just say get clone. Actually, let's switch user. I'm sorry. Let's switch user back to Kali. And we'll enter here. And then what I like to do when I install tools is I like to install them into the op folder, the OPT folder. So from here, we're going to run git clone, paste that. Actually, we're going to run sudo git clone. I apologize. And then enter your password. And now, if we look in here, we should have pimp my Kali, which we do. So if we cd to pimp my Kali, and now we ls, we can see that we have the pimpmykali.sh script. If you come back into the website, it will tell you how to run and operate this. Any decent GitHub will say, hey, here's how you run this script. So it says, hey, you just run sudo pimpmykali. This is for a new Kali VM. You just need to run menu option N. We're going to copy this and paste it. And then we're going to run it. So now this tells you, what do you want to do? Well, here's all the different options. N is a new VM setup. Run this option as your first time running pimpmykali. Okay, so that's going to fix all the things for you. I'm going to go ahead and hit N and let this run. It's going to go out and fetch some stuff from repositories, and it's running apt update. And now it's going to install certain tools and packages and uninstall certain tools and packages. As you can see, it's rolling through here. So go ahead and let this run. I'm going to pause the video here for a second and then meet me back when you're at the next screen where you can actually enter in any sort of command. Okay, so it's been about 5 minutes and we get to this page here. And you can see that it's asking us if we want to run root login installation. It explains that in Kali 2019.x, the default user used to be root, which we talked about early on in this course. And now that they've switched it to Kali, which is what we've been using. Now, do we want to re-enable the ability to log in as root in Kali? In this instance, I'm going to choose yes. However, you need to make sure that you are comfortable and capable of running as root in Linux. If you do not feel comfortable, stick with running as Kali. You're going to see me throughout the course as we get into the ethical hacking section running as root. Just know that there may be times where you might need to use sudo, or you may need to switch user into root, as you saw me do with upgrading packages just a few minutes ago, that may be required. So if you're understanding of that, you can hit no on this screen, and that's perfectly okay. Security best practice suggests to hit no. I'm going to hit yes because I feel comfortable running as root. I'm the only user on this machine, and I don't have any accountability or repudiation to worry about. So I'm going to give a new password for this. And I'm going to enter it again. And now it's going to ask if we want to copy everything over from our Kali folder into our root folder. I'm going to say no. And now it's going to continue on installing. So we're going to let this run again. Go ahead and pause the video if you need to, and then we'll meet you back when this is all said and done. Okay, and when everything is said and done, which it took about 10 minutes to get through all of that, you should get to this all done, happy hacking screen right here, and everything should be installed for you. If you chose to go the root route, that's a weird thing to say. If you chose to go the root route, you can log out and log back in as root and begin using Linux as root. Otherwise, you can continue on with this lesson using Kali as your main user. So we're going to go ahead and move on to the next video. Last video in the section, and this is going to be one of my favorites. So what we're going to be talking about is scripting with Bash. I'm going to show you some cool tricks that we can do to kind of narrow down some of the results that we get, and then I'm going to show you how you can automate some of that process, And we'll take that and even write out some for loops and one-line loops, which this might not make any sense right now, and that's absolutely okay, but by the time the video is done, hopefully it does. So the first thing I want to show you is I want to show you how we're going to write a ping sweep. So we're going to write a ping sweeper. Basically, we're going to go out and say, I want to ping a device. If that device is alive, go ahead and show me that result. And we're going to sweep an entire network. So what we're going to do first is we're going to identify a device that's alive so we can test this out and then build upon that. So you can go ahead and type in ifconfig and then just hit enter. Now my Ethernet here is on a NATed network. So I'm running through a different IP address subnet here. So this one is 192.168.57.150. My actual IP address is on a .4.x here. So I'm going to, for this example, I'm going to be pinging 192.168.4.29. However, and you can see here's the ping that we're getting back. However, if you are unsure of a IP address in your house that is active or your subnet in your house, that's okay. You can just run 57.1 for this example. You might not get a lot of return results. However, you might only get 1 or 2 when we do this sweep. So I advise you to figure out what your IP address is. That's a good challenge anyway. And if you are familiar with networking, which you should be at this point, then you should be able to determine the IP address of your home network. But if you do not do that, then you can use 57.1 or whatever your IP address is here on this third octet. So that will also work if you see that. All right, so I'm going to clear this. Now, what are we noticing when we're pinging? We're pinging this address and we're getting some data back. Now, if we ping an active address, you can see that we get, okay, 64 bytes from 192.168.4.29. It's saying it's active. We're getting details back. If we were to ping something, let me do like 41, where we just don't get any data back. Okay, and let's try this one more time. Let's try this a different way. Let's do like a count of 1. -C of 1, we'll do a count of 1. It's going to try to send one packet over and see if it works. Nothing's happening, right? It's trying to transmit that packet. You could see that it's getting 0 received here, where here's getting 4 received. No data is coming back. It's just not doing anything for us. So the thing that we can identify here is, what's the big difference? If we look at line 1 and 2 versus line 1 and 2, what are we seeing when we get data back? Well, the big difference here is well, 2 of them, I guess. We see that we get this response, right? That's big difference. And then down here, it'll say, hey, we received some packets if it's not 0. Now, the easy way to do this is to look at a line that says, hey, we received data, which is this line here, okay? Now, what I want to do is I want to narrow this down just a little bit. What we're going to say is we're just going to do a ping of 1 time. So I'm going to clear this. I'm going to bring it back to this like this. I'm going to do a count of 1. And that should just ping once. And that's perfect. We don't need to ping endlessly. We just want to make sure we can ping once and then we're done. Okay, and then from here, I'm going to put this into a text file. I'm just going to call this ip.txt, just like that. So when I cat out ip.txt, now you can see that I have this file. It's stored. I don't have to run the command again. We're good to go. So what we're going to do now is we can take this and then we can start gathering data based off of what we see here. So what I want to do is I want to just extract this one line here, the 64 bytes from 192.168.4.29. And the best way to do that is with a command called grep. So grep is going to look for a specific term or phrase, and we can do that, and it's going to pull down any line that has that term or phrase. So if I say grep here, and then I just put in quotation 64 bytes, like this, now when I cat out this, all I'm pulling down is this line, and it's even highlighting it for us. It's saying here's the line that we see, 64 bytes from 192.168. Okay, so we've extracted just the one line. And why am I extracting this line? Well, if we're building out a ping sweeper, what I want to do is I want to sweep every single IP within a specific subnet. So say this .4, right? I want to ping 4.1.2.3 all the way through 254, 255. I want to see if I can get through all the IP addresses in a subnet. So what we're going to do is we're going to ping every single one of them and say, hey, are you up? Are you there? And we're going to do it with a count of 1. and we're gonna say, are you there? Okay, and if they're there, they're gonna say, yeah, I'm here, 64 bytes, here's my response, and it's gonna say 64 bytes from this IP address. So we want to extract the IP addresses to say, yeah, we're alive. That's basically our goal here. So when we run this on a bigger scale, which is what we're going to do, we're going to need to grep out this information and extract this information to where we only just get the IP address back. Okay, so what we're gonna do now is we're going to start narrowing down and grabbing this IP address, and then I'm gonna show you how we're gonna take this all in one instance and run it and then extract IP addresses. So from here, what I wanna do is I want to do another command. So every time we pipe, we're saying, hey, run this command, then with that command, run this command, then also run this command too. So we're going to keep running this command on top of this to narrow things down. So here's what we're doing here. We're gonna run a command called cut. And with cut, we're gonna say, I wanna cut something out of this. We need to provide it what is called a delimiter. So we do a -D like this. And the delimiter I'm gonna use is a space. And then I'm gonna say -F for field, and then I'm gonna say 4. Okay, what is this doing? Well, it's saying, hey, I wanna cut this line that you're getting back on a space. So the delimiter is a space. So here's a space, here's a space, here's a space. And it says, I wanna count up to 4 to grab that data. So 1, 2, 3, 4, right here. So if we say 4 here, like this, we hit enter, we're grabbing that specific IP address because we're doing it by spaces. If we did it on 3, what do you think we're gonna grab? We're gonna grab the word from. So you can see here's from. So what I wanna do is grab the IP. So we're going to use this cut just like this, use our delimiter, and then get to the correct field position that we want to grab the IP address. All right, so we've got the IP address. Now there's only one thing wrong here with this IP address, is that there is a little colon on the end of it. We just want this without a colon at all. We want it just like this. Now there's a couple ways we can do this. We could use something called sed. Sed's a little bit complicated and a little bit advanced, I would say, for where we're at right now. So I'd rather teach you an easier way to do this. And that is called translate. So with translate, all we're gonna do is we're going to do one more pipe like this, and we're just gonna say TR for translate, a -D for a delimiter again, and then we're gonna say we wanna get rid of this. And that's it, we're just getting rid of this. Okay, so if we run this one more time, now you can see that we've successfully extracted this IP address out. That's our goal, that's all we wanted to do. Now, how can we apply this to something bigger? How can we make this part of a bigger script? That is the question, and we're gonna do that. So what I want you to do is I just want you to copy this, okay? Copy this entire line, and we're going to go into a mouse pad. So let's copy this selection, and I'm gonna clear my screen. I'm just gonna say mouse pad, and we're gonna call this ipsweep.sh. Okay, so this is going to be a bash script, and I'm gonna make this bigger. And the first thing we're gonna do with our bash script is we have to declare that it's a bash script. We're gonna say #bang right here, or shebang is what we'd call this, /bin/bash. This allows the machine to know when we run this, allows bash to know, hey, we're calling this, here's the location of bash, this is what we're running with the script. You're also gonna see this when we use Python as well. You'll see the declaration here at the top, or when we're calling this out. So I'm gonna go ahead and Control S and save this. That'll add some nice color to this, so when we're coding this out, we get to see in color. I like that a lot. I'm gonna actually make this a little bit smaller and then make this like this here so we can get the whole picture. Okay, so what I wanna do is I wanna paste in what we just wrote. So I'm just gonna Control V here and paste that in. So we don't need to do a cat of an IP address here. In this instance, instead, we're gonna change this back. We're gonna ping. Remember, we wanna ping every device in the network. So we want to ping, say if we're pinging 192.168.4.x, okay, we wanna ping that. And we can leave this like this for now. Don't worry about changing anything here. This is just gonna be a placeholder. We're gonna do a little bit of extra syntax here to make this work. So we're going to write what is called a for loop. So we're going to say for, and I'll explain what this does here in a second. You're also gonna see this again when we get into Python and coding. And so you'll be able to understand more and more about loops and what for loops are, while loops, etc. They're very, very useful and very common in coding and scripting. So I'm going to say for IP in, and then I'm going to say sequence 1 through 254. Now, very important, this character here is not an apostrophe. Okay, this is not an apostrophe. This is the little line, I don't know what it's called. It's above the tilde next to your escape button on your keyboard. So it's this right here, okay? It's like a backwards apostrophe almost. I'm sure there's a term for it, I just don't know it. So you come in here and you say, okay, for IP address in sequence 1 through 254. And I'm gonna explain what all this does in a second. I want you just to type this out for now. I want you to say do, all right? And then I want you to come down here and we're going to say ampersand on this line and we're gonna say done. I'm gonna explain what all this means. Okay, so this is a loop that we've just created. What we're saying is for the IP address, and we're just declaring this. This could be Bob if you wanted to. I'm just making it a name or a term that's easy for us to remember. So we're gonna say for IP. But if you wanna call this Bob, call it Bob. For IP in sequence 1 through 254. So what sequence is doing is it's saying, hey, I wanna count everything from 1 to 254. So 1, 2, 3, 4, 5, 6, 7, 8, all the way to 254. This for loop means I'm gonna do this every single time. So for IP in 1, for IP in 2, for IP in 3, we're gonna run this command until we're done. So until this sequence has run 255 times, it's done. Okay, and now we're gonna say, I wanna do a count of $IP. So what we're saying here is for IP in sequence 1 through 254, go ahead and do a ping -C for a count of 1, 192.168.4, 254. And here we're gonna say .1, .2, .3. Every time this loops over and over and over, it's going to be incrementing that number through this sequence. That's all we're doing. This is a basic loop, okay? So we're gonna keep going through and through and through. Now, this will work. If you plugged in your hard-coded IP address here, this will absolutely work. Now, we can improve this just a little bit if we want to. So what's going on here is what we're gonna say is if we wanted to run this, we would just do ./ and then IP sweep, okay? And this would work, that's fine. But we can make this a little bit better from a coding perspective. We can come in here and we can give this a $1, and that means argument 1. So what we're saying here is I wanna give an argument instead. So if you wanna be technical, this first ./IP sweep.sh, that is argument 0. So you can consider this $0. Argument 1 would be what you type after that. So this would be argument 1, argument 2, etc. So in this case, what we can do is we could say, I want to run 192.168.4 like this, and this will run the .1, .2, .3 after it. So you provide the argument, it places that here in argument 1, and then it does the rest for you. So this way you can specify your network, and if you wanted to ping multiple networks, you don't have to come back in here and keep changing this. It just works. So super easy. This is a great little script for a /24 type subnet, okay? Okay, so let's go ahead and try running this really quick. I'm gonna just Control S, save this. I'm gonna close it. We're gonna do a chmod +X on IP sweep. If it'll allow us to, we might have to do a, okay, let's do LSLA real quick, make sure it worked. It sure did. Okay, so here's what we're gonna do. We're going to run the IP sweep, and we're going to say 192.168. You just put in your IP here, and I'm gonna run that, all right? And you could see all the devices that are coming back within my network here. I'm gonna go ahead and hit Control C, cancel this out. And so this is grabbing all the different devices in my network. Now that's great. That works out really well. But what we can do is improve this. What if I typed in a, what if I didn't type anything at all? What if I just hit enter here? Now I'm just getting all kinds of pings unknown, and it's going off of some of the stuff I was doing before, but it just causes all kinds of issues and errors, right? So you can see I'm trying to hit Control C, it's taking its time to break. Here we get issues because we're just allowing any sort of argument here. What we need to do is we need to fix this up just a little bit. So what we can say is we can come back in here and just go mousepad ipsweep.sh and come in here and let's add a little bit extra. Oh, and I also left this in here. Don't leave this in here. That's why that was running twice. Okay, so what we're doing here is we need to add in a statement. What we're going to do is we're going to add in a if statement. If statements are conditions. We're saying, hey, if this condition is met, do something for us. If it's not met, then go ahead and do something else. All right. So we're going to say if, and we're going to just put in here $1 is equal to nothing, then we're going to go ahead and just say then echo you forgot an IP address. Echo syntax, something like this. We'll just say IP sweep.sh and we'll go 192.168.4 like that. Okay. And then if we did do this correctly, if we do have an argument inside of argument 1, then we're going to say else, do all of this here, and be done. And then we're going to end our if statement with fi. Now, this script, or this resemblance of this script, is not one of my own, by the way. This goes credit to something I've modified over time, but the original credit definitely goes to Georgia Weidman. I remember seeing this in her course a long, long time ago when I was first getting started. And she did a great job of teaching this. This is just a modification of this script. So I just want to make sure that all credit goes to her. But looking at this, let's break this down really quick before we run this again. We've got an if statement. We said if argument 1 doesn't equal anything, then you're going to echo back out and say, hey, you forgot an IP address. Here's the syntax. If it does include something, then we're going to go ahead and come in here and say, let's run our for statement, our for loop, and run through it, and then we're going to end our if here. The only thing that I'm doing uniquely here is I'm including this ampersand, which is going to run this command multiple times at once. This is a good way to explain it. Basically, we have a couple ways of doing this. We could say like this. We could put a command here, and this will run one at a time. It'll say, okay, for 1, for 2, for 3. This allows multiple instances of this loop to run at once and just speeds things up. I could show you the difference between that. So I'm going to go ahead and just Control S, save this. I'm going to go ahead and just run this script real quick. Now let's try running it without anything here. Okay, now look, it says you forgot an IP address. So look, we did that correctly. Now let's go ahead and add the 192.168.4, run it. And you can see, okay, it's sweeping, but it's taking its sweet time, especially for the IP addresses that are going to hang. Like if I don't have a .2 or .3, it's going to take a while. So I'm going to Control C and get out of this if it'll let me. And it looks like it's actually going to hang. So what we can do is we can come back in. I'm going to open a new tab real quick just while that's waiting. And I'm just going to say mousepad, and we're just going to go back into ipsweep.sh. It's in this folder. There we go. Okay. So from here, I'm going to change this back to the ampersand, and I'm going to save it. I just want you to see the difference really quick and why I run it like this. So ipsweep.sh 192.168.4. You can see it's picking everything up really fast. All right. What I can do now is I can run this and then store this into like ips.txt, something like that. Just like found IP addresses. Okay, so now if I cat ips.txt, I have all the IP addresses I just found, and I found them that fast versus this, which may still be going. And it is, and I can't even kill it. I'm just going to close this out. Okay, so this is the big difference there with that ampersand and the speed of what it is capable of doing. So with all that being said, we could take this and do one more thing. So I want to show you how we can utilize a one-liner. These are called one-line statements in Bash, and we can do similar to what we just did and accomplish that in this command line. So now we have an IP address. We have a list of IP addresses. Let's say that we want to run nmap. Now we haven't gotten to nmap yet. You don't need to really know about it. Just know that it is a tool that allows us to go out and do port scanning. Okay, so typically we would just say something like nmap, and we might do something like T4-A-P- like this. This is just saying, I want to run nmap scan, I want to look at everything, and I want to scan all ports. This is just an example. You can just run nmap IP address like this, and that would be fine too. Like we could just go 192.168.4.29, and we'll do a quick nmap scan. Okay, but what we can't do here is we can't just say, hey, I want to run, well, we could say, I want to run nmap for everything in .0/24. The issue is it's going to take time looking and finding what IP addresses are valid here. If we have a list, we can automate this process quite a bit. We can just come in here and we can say something a little bit different. We can say, hey, for IP, we're using the same kind of syntax, in $, and we're gonna put parentheses here, we're gonna say cat, and then we're gonna say ips.txt, and then we're just gonna do this. We're gonna say do nmap $IP, and then again, we have the option of doing done, or we can do ampersand done, just like this, okay? I'm just gonna do done here as an example and just show you. So this is really easy. We're saying, hey, for every IP address in this list, and all we're doing is we're catting out this IP list that we just had. So it's gonna take the first IP, then run the nmap scan, and it's gonna come back and run the next one. So until this list is completely done, it's gonna keep going through this loop. That's all it is, a simple loop. And then we're gonna say done. It's gonna take that IP address, it's gonna start scanning it, it's gonna go through and hopefully find information and go in a loop. So this is a quick way to automate some of this process. I actually do this with a lot of my scripts where I will do some probing, see if anything is out there that's alive, put it into an IP file, and you're gonna see this later in the course, and then nmap scan that. So think about this. Hopefully this gets your wheels spinning on what you can do to really start scripting some of this stuff out. And this is going to be the first time you get your hands dirty with scripting. We're going to go on again with this, and we're going to get more advanced as we go. But this should be a good introductory lesson to you on how we can build a simple tool and automate a lot of this process fairly easily with just a little bit of command line syntax. So we're going to go ahead and move on to the next section, and I will see you over there. Welcome to this module on Python. So if you've never used Python before or even heard of Python before, Python is a coding and scripting language. It is commonly used in ethical hacking, and it's commonly used all around the world. It is actually considered one of the best beginner languages to start with if you've never learned coding before. So that's exactly what we're going to do. We're going to cover some of the basics of Python. So we'll cover everything you see on this screen here: strings, math, functions. We're going to get into conditional statements and looping. We'll get into some more advanced items, and eventually we're going to build our own tools. So we're going to be building a port scanner at the end of the lesson. And then when we get into the exploit development section of this course, we're going to use Python again to write our own exploits. So it's going to be used throughout the course. You're going to see it again as a ethical hacker as well. You're going to go on to websites and you might need to download Python code or something to utilize against a host or a client, and it's just going to be frequently seen for you. So very important topic to cover, especially for the foundations. One very big thing to point out: you do not have to be a developer to be successful in penetration testing. The important thing is that you understand what you're seeing and understand how to read code. If when you come away from this module, you have a better understanding on how to read what you are seeing in code, you'll be much better off. By no means do you have to be a developer. I am still to this day nowhere near a developer level, and I'm very, very successful in what I do. You don't have to be a developer. So the big takeaway here is to take very good notes, understand what you're seeing. If you need to watch a video multiple times in this section, absolutely okay. Just make sure you understand everything in front of you and understand that the lessons are going to build upon each other, and it should all come together in the end. And you're going to get to see it over and over through the course, especially in the exploit development section where we write our own Python script. So I look forward to teaching you this module on Python, and look forward to seeing you in the next video. Okay, on to our first lesson. The first thing that we're going to cover is going to be strings. And in order to do that, I'm going to go ahead and make a directory on my Linux machine. You can make a folder in your Mac or your Windows machine if you're using those operating systems. I'm just going to go in here and just say make dir python, and then I'm going to go ahead and go into that directory. So from here, I'm going to go ahead and make my first script. So I'm going to clear my screen with Control L, and I'm going to say mousepad, and I'm just going to call this script first.py. And I'm going to give it the ampersand here at the end. That's just going to allow me to open up this process of mousepad and also have the terminal available to me when I need it. So you'll see why I do that here in a little bit. Now, if you're not on Linux, that's okay. You can use something like Notepad++ or Code Runner for Mac, which we showed earlier in this course. So from here, what I'm going to do is I'm going to go ahead and enter in a shebang, which is a hash and an exclamation /bin /python3. And this is important for Linux here because we are calling out the directory. If you're familiar with Linux, what's happening here is we have two options. We can come in here and we can say python3 and we can say first.py, and that'll execute our script. Or in theory, we can come in here, we can just do a ./first.py and run it that way. If we run it like this, our script will not know where to go unless we declare that. So up here, we're giving the shebang /bin /python3. That is where python3 is located in this machine. So we'll come up here and it will look for this first and say, okay, I'm going to execute this based on python3. So that is a little bit of a Linux nuance here and something you should know in case you are ever coding in Linux or an environment that is similar like Unix, which Macs do run off of. So from here, if you've ever taken a coding class, the first thing you do in every single coding class is what is known as hello world. So we're going to print out hello world and print it to our terminal. So in order to do that, we're going to go ahead and do something like this. We're going to say print, and then we'll do a parentheses and we'll say hello world. I'm going to go ahead and save this. And if we run this, and I'm going to run this with python3, if we run this, python3 first.py, you'll see that it says hello world. Now, one thing that we can do in here is good practice for being a developer is add some notes in. So we're going to add a comment in here. We're going to do a hashtag or a pound symbol, and we're just going to say print string. Now, when we run this again, this isn't going to print out. Comments are just for us inside of the script, and I can prove that to you by saving this and running it again. You'll see all we have in here is hello world. Perfect. So comments with a hash are just meant for whoever is reading your script or your code. And that could be you, or bad scenario, but what if you get hit by a bus tomorrow? You're the main developer and nobody knows how to read your code because you didn't leave any comments. That'd be very bad. So good coding practice suggests to leave good comments and make sure that people can come in and read your code and understand what is going on in here. So we're going to add comments along the way so that way we understand what we're doing and practice good habits as well. So what you're seeing here is what's called a string. You're seeing a string in quotations. And you can see a string printed out with single quotes as well. So we can just do hello world. I'll add the exclamation for consistency. And if we save this and print this, you'll see that it also prints hello world. So it really doesn't matter if you have single quotes or double quotes until we get into more advanced strings, and we'll talk about those a little bit later on in the course. But for now, just know that you can use single quotes or double quotes when printing out a string. Another thing that we can do with strings is print on multiple lines. So if we say print and we do triple quotes like this, we say this string runs, and then we hit enter, multiple lines with an exclamation and add in 3 more double quotes there. and close this off, we can add a note here as well that says triple quote for multi-line. And if we save this with Control S and we run this again, you're going to see this string runs multiple lines. Awesome. Another thing that we can do is concatenate strings. So we can print out something like this string is, and now we're going to add a space at the end of it. Make sure you have a space right here. We're going to do a plus sign, and then we're going to say awesome. Just like that. And we can say we can also concatenate. It's always hard for me to spell that. So what's going to happen here is it's going to take this string plus this string when it prints out. So the reason we have a space is it's got to have the space because there's no space here, and this won't just add a space for us, even though in our heads we might want it to. So we're going to go ahead and save this, print it out one more time, and you can see that it concatenated and said this string is awesome. Now, one last thing. We can also print out a new line. So we can just do something like this. And we can use a single quote this time just to do a proof of concept. Do a \n like this. And this will print out a new line. And we'll get familiar with that later on. As we get into functions, we'll write our own function to make a new line. But for now, if we wanted to add another line, we could, and then we can just print test that new line out. And let's see if it actually gave us a line printed in between this concatenation and this new print statement here. Let's go ahead and save that. We'll print it. And you can see there is a line here. So the \n will print out a new line for us. And that is all we need to know for basic string. So we're going to go ahead and move on to math. You can go ahead and leave this open. We're going to run through this as we go, and then you'll have a long script, which will also make for very good notes. Let's go ahead and move on to math. So math. Python actually has a built-in math interpreter. So we can do a bunch of fun stuff with Python and with math that's automatically built in. So I'm going to go ahead and just call this section math. And if you want to keep track of sections, you can come up here and just call this strings and just capitalize it like that. And then that way we kind of have an idea of where we're at. You can even add an extra line here if we want to. So from here, let's go ahead and play around with math just a little bit. So if I wanted to do a print of 50 plus 50, we can definitely add. We can also subtract. So if you want to do 50 minus 50, you could do that. And I'll give you some time to catch up here in just a second. I'm just going to do a few print statements, then we'll take a look at them, and then we'll move on to some more math as well. We can also do 50 times 50. And we'll just use the little star or the asterisk. We'll just say multiply. And we'll also do 50 divided by 50. We'll just say divide. So if we save that, you could take a second to catch up. You could see we are just doing simple math here. We should expect 100. We should expect 0. We should expect 1 here and 2,500 if my mental math is correct. So I'm going to go ahead and print this out. Okay, and we've got 100, 0, 2,500, and 1.0. So this 1.0 is a little bit different. This is what's known as a float. Everything else that has come out so far is just an integer. And we'll talk a little bit about that here in just a few minutes, but know that integers are on the left-hand side. And if we don't have a decimal point here, we're looking at integers. And on the right-hand side, when we see anything on the right-hand side of the decimal, we're looking at what is called a float. And that becomes very important depending on when we need it. For now, we're going to keep worrying about math. We'll get into integers and floats in just a little bit. So another thing that math built into Python can do is it can do PEMDAS. If you've never heard of PEMDAS, please excuse my dear Aunt Sally. So parentheses, exponents, multiply, divide, add, subtract. You may have had it something different within your educational experience, but it will do that for you. So if you do 50 plus 50 minus 50 times 50 divided by 50, it will give you the answer. I don't know that mental math offhand. Another thing that we can do are exponents. So we can print, say, 50 to the second power, which is the same thing as 50 times 50, which would be 2,500 as well. And we can get exponents out of this. And we'll actually go ahead and save this and run this here, because the next stuff I want to be able to lay out clearly. So you can see that we have successfully done the math here. It did it for us. Awesome. And it also did the exponent for us as well. So now, a couple of weird things with division. So you saw the 1.0 before. Well, we have a few things that we can do. For example, the 50 divided by 6, but using a percentage sign is what's called a modulo. And that, it just takes what is left over. So 50 divided by 6 is not divisible. There is a leftover. So if we print that, you'll see we get a leftover of 2, which makes sense because 6 goes into 50 8 times. 6 times 8 is 48. And then we have 2 left over. So if we want to know what the remainder is, we can use a percentage sign here. We can also do something like 50 divided by 6, like we saw earlier. And this will have division with remainder. So we can say or float. We'll save that and take a look at that really quick. You can see we get 8.3, and then it rounds up eventually to a 4. And lastly, what if we wanted no remainder? So if we just did 50 divided by 6, we say no remainder. We could do this, and we should get 8 here. So depending on the situation and what we want, we might want a situation where we only want the integer, or we only might want what's left over, or perhaps we actually want the whole number of what's being divided. So there are a few different ways to divide with math in Python, and it's good to know all of them depending on the situation that you run into. So for now, just take notes on this and know that there are a few ways to do math and division, and you can do PEMDAS and exponents and all kinds of fun stuff, and this is just scratching the surface of math with Python. So that's it for this lesson. We're going to go ahead and move on to the next one, which is going to start covering variables and methods. So I'm going to come in here and I'm just going to call this section variables and methods. And if we want to make our script a little bit clean, we can just come in here and copy this new line. It'll be a lot easier once we write a function for this, but we haven't gotten there quite yet. So we're going to print out this new line, and that way when we print this out, you could see that we have kind of gaps in between the sections that we're working on. So now we're going to work on variables and methods. So variables. Variable means something can vary. It can change, and we're going to look at that here in a second. So if we have something like quote, and we make quote equal to all is fair in love and war, and this is what? This is a string. We are storing this string inside of this variable called quote. And we can just come in here now and we can print out quote. And if we do that, we should get this returned back to us. You can see all is fair in love and war. If we didn't print this, just go ahead. Actually, we'll just comment this out. This is a great way to test the script. If we just save this now with a comment and we hit enter, there's nothing here. We haven't given it any instructions to actually print out. So now we can print this out, and it's printing whatever is stored inside of that variable. In this instance, we have a string stored in there. Now, when we talk about methods, methods are just functions that are available for a given object. Now you could think of functions as something built into Python that allows us to do something. And it'll make sense here when we get into using methods. So we have this quote, "All is fair in love and war." Well, what if we wanted to print this in a few different ways? Well, we can use methods to do that. For example, we can print quote in uppercase and just do upper like that. And this is going to make it all uppercase because we're giving it this period, upper, and then open close parentheses right here. And that is allowing us to use that method. So we can say uppercase. And we can also print in lowercase if we do lower. And just for one more, we can also do print, and we'll say quote.title. And this is what's known as title case. And title case will capitalize every single letter like it is the title. In this instance here, we're going to get like the A capitalized, which wouldn't really be true in a title, but still just know that title case is meant to capitalize every first letter within your string or your sentence in this case. We're going to call this lowercase here. Okay, so let's go ahead and save this, and we're going to print this out. And you can see the differences that we have. We have it here in its normal quote, and then we have it in uppercase, all lowercase, and then every single first letter capitalized. Perfect. These are methods. These are just a small example of methods we're going to get into more a little bit later. Here's another example. What if we wanted to print the length of quote? Let's say we wanted to know how many characters were within this sentence. So this is going to count the characters. And this will also count spaces. So we're trying to get a total count of what's going on inside this string. We print that, you'll see that we get 28 return. So if you want to check that, you can go count every single character within here and you'll get the length of that. And that could become important as you're doing Python later on. And this is just yet another example of a method. Now let's go back to looking at variables and why they're called variables. So let's say that we have a variable of a name. And in this instance, I'm going to use my name and I'm going to make it a string. And I'm going to use my age. I am 33. And here we're going to say string just so we can make sure we notate the differences. This is an int or an integer. And we're also going to give a GPA. Let's say I went to school and I'm going to use the American grading system. Let's say I had a 3.7 GPA. And this is what's known as a float. And that has a decimal. So make sure you notate that. So if we print these out, if we print out the integer of age, that'll still print 33. What if we print out the integer of 30.1? Save that. Take a look. And you'll see that we just get 30. All right. And you can see that this rounded down. Again, integer, just the first number, just what's on the left side of the decimal point. Doesn't care about the right side. What if we printed integer of 30.9? Will it round? Will it round? No. So if we save that and we print again, you'll see it's still 30. It doesn't care what's on the right side of the number. It's only going to take what the integer is. So anytime you print an integer, you're only going to get the first, or what's on the left-hand side of the decimal point. So make sure you know that. Now, a few cool things that we can do. Let's say that we wanted to print something like this. If we print my name is with a space, and then we'll do plus name, and we'll say space again, and I am space age plus space years old. Make sure you have your spacing in there properly. That way you can account for the spaces before and after these variables. But what are we doing here? We are concatenating variables. Now, if I try to run this, I'm actually going to get an error. If I run it, we're getting a type error. And this is a great example, by the way, of understanding what Python is telling you. I get emails all the time from students saying, I don't understand why my script isn't working. And the first thing I'll ask them is I will say, did you read the output of the error? Because it tells you, it says, hey, on line 44, if I control tab, look, this is line 44. It tells you where your mistake is. And then it also says, can only concatenate string, not int to string. So if you didn't know what this meant, and maybe you don't, you can copy this, go to Google and search it, and I promise you somebody will have had this error before. As much as we wish to be special, there's not many situations that will come up where there hasn't been this error or an issue that we run into that somebody hasn't already had before. So with that in mind, we can fix this. So it's saying that it can only concatenate strings, not integers. Well, name is a string, but age is an integer. So we need to make, in this situation, age a string. So what we're going to do is just say str, like this, and give it like that. And now if we print this, save it, print it, you can see my name is Heath and I am 33 years old. Perfect. Now, what happens if I am a year older? Well, I could take age and do something like plus equals 1, something like that. And if I print age now, hopefully, we are seeing 34. You can see 34. Now, this is what comes into play. This is a variable. Variables can change. At this point in the script, we define that we are 33. And as we run through it, I am still 33 when I print this statement out. However, I've had a birthday now. Age has increased by 1. Printing age out now will say that I'm 34. So variables can change. Variables can store different numbers at different times. That's why they are called variables, because they vary. Now, we could also do something like birthday and set birthday equal to 1. And I could say age plus equals birthday and then print age. And guess what? Now it's going to return 35. So just know that you can store a number within a variable. We've shown that before already. We can add two integers together and we can print them out. So we're adding those together and it's taking that total and adding that to age. And now it's saying we're 35 years old. So that is it for this lesson. We're going to go ahead and move on to functions and fix this new line issue that we've had, plus write some pretty cool stuff out and build some other cool functions out as well. So I'll go ahead and see you over in the next lesson. All right, moving on to functions. So let's go ahead and print out a new line really quick. And we're going to call this functions. Now, I like to think of functions as mini programs. What they are is an organized block of code that you define, and then you can call it later instead of repeatedly typing the code out. So we're going to take a look at some examples of that. So let's go ahead and write a function. So let's do a define def, and that's how we start a function. And in this one, I'm going to say, who am I? And I'm going to do close parentheses. And here we're going to say, this is a function without parameters. And we'll talk about that here in just a little bit. Now, indentation is incredibly important in Python. If we do not indent, we will throw an error here. And you're going to see a lot of situations where indentation becomes incredibly important. It's one of the most important things in Python. Python does not have a lot of rules that apply to it, but indentation is one of them that you must follow. So we're going to go ahead and hit the tab to indent. And I'm going to say my name is Heath. And this is what is known as a local variable. We'll talk about that here in a second as well. Age is equal to 30. And we're going to go ahead and print. Same thing we did before. We can actually just kind of copy this up here. We'll say my name is just like this. Okay. Copy all that, paste it, and then add the close parentheses there. I'll let you catch up. And then we can just call down here, who am I? So what's going on in here? Well, we have a function that we're defining. We're calling it who am I? And it has no parameters. We'll get into parameters here in just a second. Now we're giving it some items within this. In this instance, what we're doing is we're giving this local variables. We're saying, hey, in this instance, when we have a variable of name, it's going to be Heath, and the age is going to be 30. Well, whatever is stored in here is only stored within the function. That's why this is a local variable. If we print age as well, we'll see that. So we know that age was 35. We called age over here as 30, and let's see what happens. First of all, we called our function here. We said, who am I? Called that. And all it does is run our mini program. Our mini program says, hey, I'm going to print out these variables into this string here. Okay. And that's exactly what it did. But when we printed age again, you can see that we're actually still 35. So this variable, or the variables that are within a function, are local and do not apply outside of the function. So make sure to remember that. Okay, so I'm going to delete this print statement. We don't need it. And we're going to write some more functions. So let's do one where we add some parameters. So we're going to do add 100. And we're going to give this a parameter of num, N-U-M. And that's just going to stand for number. Okay, we're going to indent, make sure we indent. And all we're going to do is print num plus 100. So when we call our function, we say add 100, just like last time. This time we have to actually give it what is called an argument. So our argument goes with our parameter here when we're calling it. So our argument is going to be 100. And when we print this out, this is going to be 200, hopefully. So we'll save this, run it. And you can see that we got 200 because we're doing print 100 plus 100. That's all we're doing with this mini program. Okay, let's try another one. Let's say we want to have multiple parameters. Let's do define add, and we're just going to add X and Y. This one's going to be easy. We're just going to say print X plus Y. And now we can add whatever we want. So let's add 7 and 7. And one will take the place of X. The other one will take the place of Y. X plus Y, 7 plus 7 should be 14. Let's go ahead and run that. You'll see we get 14 here. Beautiful. All right, let's make it a little bit more complicated then. All right, let's try adding in here another function. This time we're going to do multiply. We're going to do X and Y again. And instead of doing a print, I want to show you something a little bit different. Let's say we just return X times Y. Now in this instance, if we multiply 7 times 7, do we get 49? We don't. Okay, there's a reason for this. This is just calling back. So when this is saying return, this isn't saying print. Remember, this says print. This is going to return X times Y. So we can call this here, this function, and it knows that this function is equal to 49, and perhaps we can put that into something else. Like we can put that maybe into a variable or whatever it is we might want to do with it. However, if we wanted to return it to the screen, we actually have to call that. So sometimes we're going to actually store something instead of printing it. We do a lot of printing in Python tutorials just so that you can see it on the screen and make sure that you're seeing what you're doing and that everything's printing out okay. So that's why we're doing this. But please understand that the return option does exist and is used quite frequently. So I'm going to save this and run this. And you can see now that we get 49. Perfect. Okay, 2 more. Let's say we want to do a square root. Okay, so let's define square root. And we're just going to give it 1 parameter. And in this instance, we're going to print out the square root. So we're going to take x, and a square root in exponent format is just to the power of 0.5. That's all we're doing. And we can test that theory by doing something like square root of 64, which we should return as 8, because 8 times 8 is 64. So if we save that, come in here, print it, and you can see we get a float of 8.0. Now, I told you we would create our own function for a new line, and we're going to do just that. Let's go ahead and define new line. And we could call this like new line if we wanted to or whatever, but I think to make it simple, as long as we understand what it is, we can make comments and notes in here if we wanted to. We could just say define NL, and then we can just say that when we do that, we're just going to print out our N for our new line. And then we call a new line, we'll get one. Very simple. So we can just even say in here, new line. Okay, so now we know. And we save that and we can print it. You'll see it. It's here, but we really don't have anything after it to really show it, but we do have that space there. So that is it for this lesson. I'll go ahead and see you over in the next one. Next up, we're going to learn about Boolean expressions and also relational and Boolean operators. So let's go ahead and type in here Boolean expressions. And when we think of these, we can just think of this as true or false. That's really what it is. So from here, let's do a few variables. So we could set bool1 equal to true. We're just going to say, hey, this variable's true. Bool2, we could set equal to 3 times 3 is equal to 9. So the double equals means that something is equal to something. So we have 3 times 3, that's 9, equal, that means that equals 9. Do not confuse that with setting up your variable. This is saying, hey, my variable is equal to this, but this is saying this is equal to this number. Okay, and that is a true statement. We could also say bool3 and make that false. Or we can give it a statement that makes it false. So something like 3 times 3 does not equal 9. Exclamation equals means does not equal 9. Now, if we print it out, bool1, bool2, bool3, and bool4, just like that, and save it, and if we come in here, you'll see that it says true, true, false, false. Again, Boolean expressions. Is something true? Is something false? Why do we need to know this? Well, we need to know if something is true, then we might want to continue on. Or if something is false, we might want to do something. And we'll get into that when we get into conditional statements. Like, if something is true, then go ahead and do this. If something is false, do this. Or there's something called while loops, which will allow us to continue as long as something is true. We're going to get there when we get to conditional statements as well, or looping, I should say, and we'll talk about that. But that is why we might want to know these things. Among other stuff, we might want to know if something's true, or set that parameter or that variable to true until it becomes false, etc., etc. So right now, just understand that Boolean expressions are true or false. And we're going to come in here and we're going to print, and we're going to say type, and we're going to do bool1. Okay, and this will tell us. Now, this is the nice thing. So if we come in here and say the type, it'll give us the class. This class is Boolean. Awesome. And another example of that is if we say like bool5 is equal to true, and we print the type. So if you see true and you're like, I wonder what that is that Boolean or is it actually just a string? We can come in here and say bool5. We'll save that there, and then you should see that that class is actually a string here. So you can check with the type to see what is this. Okay, so the type feature is very nice, and we can see that we are dealing with a Boolean here, and this one is actually a string. So please note that if you put it in quotations, that makes it a string. If you leave it like this, that makes it a Boolean expression. Let's go ahead and make a new line, and we're going to talk about relational and Boolean operators. Okay. So we can think of that as, let's make a variable here. We say greater than, we say 7 is greater than 5. Well, that would be true. And we are using an operator here. So the operator is the greater than sign. We're also using a Boolean expression because it's going to result in a true returned if we were to print that out. Now, we can do a few other things. We can say like less than is equal to 5 is less than 7. We can do greater than or equal to, which would be 7 is greater than or equal to 7. That's true. We can also do less than or equal to. And in that case, we can do 7 is less than or equal to 7, which is also true. So all of these statements here are true. Now we can get into some other type of operators and statements here. What if we did and? So let's just call this test, and we're going to do test and. We say 7 is greater than 5. Well, that's true. And 5 is less than 7. That's also true. Both statements are true, thus this is true. Do another one. Test and 2. And for some students, this does take a little bit to get your head wrapped around. I'm going to provide a table for you here just in a second, but just follow along and I'll explain this as we go. Let's say we have 7 is greater than 5 and 5 is greater than 7. Sorry, let me fix that syntax. 5 is greater than 7. This now becomes false. Why? Well, 7 is greater than 5 and 5 is greater than 7. That's not true. So, because it's not true, because both statements are not true, this becomes false. There's an alternative to this. What if we had an or? We said or. So 7 is greater than 5, or 5 is less than 7. Well, both statements are true, thus this is true. But we can have the same situation as before, where we have 7 is greater than 5, or 5 is greater than 7. And guess what? This statement is actually true. Because all we need is one condition to be true for this to be true. So in this situation, this is true, or if this is true, then the whole thing becomes true. So just because this is false, this would also have to be false for this to be false. Hopefully that makes sense. One other thing here, before I show you the cool little table, is we could do test not. So if we said something was not true, guess what? That becomes false. Same thing, if we said it was not false, then it's true. Not is just the opposite. So not true in this situation is false. Now, if we go out to the internet and we go to Google, we could come in here and we can just search something like Python truth table. And if we go to images, we should be able to find one that works out pretty well in our favor. Here's a good example right here. So if you ever take a coding class, you might be quizzed on this. This will tell you truth tables right here. So if it's not false, it's true. If it's not true, it's false. We can look at or statements. So true or false is true. The only situation an or statement becomes false is when both are false. Now the and, we looked at that. If it's true and false, it's false. If it's false and true or false and false, it's still false. Only situation for and where it can be true is when both are true. There's also not or, not and. There is does not equal or equals. So it's good to know these types of truth tables, and you can come and just, again, Google Python truth table and come look up this. Pretty straightforward once you get the hang of it, but it's completely okay for right now for it to be confusing. Just wanted you to know that these are out there and exist in case you are a little bit confused by this lesson. So we're going to go ahead and move on to the next lesson, which is going to cover conditional statements. Okay, we'll come in here, we'll do a new line, and we'll just say conditional statements. And we can think of this as if, then, or if, then, else, or if, else. Either way you want to write this is fine. So think about this. If you go to the store and you want to buy a drink, and that drink is $2. If you have $2 or more, you can buy the drink. If you do not have $2, you will not be able to buy the drink. So let's take a look at that. So if we write a function and we call it define drink, and we give it a parameter of money, we come in here and we say if money is greater than or equal to 2, then we're going to return, look at the indentation again. We need an indent here after our function, and we need an indent after our if statement, so make sure you're indenting correctly. Return, you've got yourself a drink. And here, we come back, we can say else, we're going to return no drink for you. Kind of like Seinfeld, no soup for you. All right, so if we come in here and we print drink of 3, meaning we had $3 at the time, and we print drink of 1, meaning we had $1 at the time, we're going to have two different results. If we have 2 or more dollars, we're going to return you've got yourself a drink. Otherwise, if we have less than $2, we're going to say no drink for you. So let's save that. You've got yourself a drink when we print out $3 because we had enough money. Here you can see with $1 we did not have enough money, thus no drink for us. Okay, let's take a look at a little bit more of a complicated one. We're going to come in here, we're going to say define. Now, I'm going to make this alcoholic beverages. If you do not drink, that's okay. You can just follow along still. You can change it into whatever you want to be. But I think this is a good example because we have a couple parameters and we can use those to make different sort of conditional statements. So let's define alcohol. Now, in the United States, we have 2 things that we need in order to purchase alcohol. 1, we have to be old enough. We also have to have enough money, similar to the drink before that was non-alcoholic, we assume. Well, we have to actually be old enough to purchase this drink. In the United States, you have to be 21. So, if our age is greater than or equal to 21, let me put a space here, by the way, sorry. And, look, the and is coming into play. Money is greater than or equal to 5. Then we're going to return, we're getting a drink. All right. Now we're going to say else if, because there's a few situations that we can be in. There's actually 4 situations here. So we're going to say ELIF, which stands for else if. What happens if our age is greater than or equal to 21 and we don't have enough money? So we say money is less than 5. Well, in that situation, we're going to return, come back with more money. Okay. And then what if we have another situation where we say age is less than 21 and we actually have money? We're just an underage person trying to buy a drink and we say $5. Well, we're going to return, nice try, kid. And then lastly, if we have no monies and we're not old enough, well then we can just return something like you're too young and too poor. Okay, and then let's try these out. So we've got these different situations here again. Okay, if we have our age and money, we meet both criteria, we're getting a drink. Otherwise, if we meet the age but no money, let's come back with more money. We don't meet the age, but we have the money. Nice try, kid. And then lastly, if you don't have the money and you're not old enough, you're going to be too young and too poor. So we're going to print out a few different statements here of this function. So let's give it 21 and 5. We'll print alcohol again of 21 and 4. Print alcohol of 20 and 5. And these should all meet different criteria. Alcohol of 20 and 4. So we should expect to get these in order. We meet what we need here. We don't. Different criteria for each of these. We'll save this. Go ahead and run this. And you can see it says, no drink for you. Actually, that's the last one. We're getting a drink. Come back with more money. Nice try, kid. And you're too young and too poor. So you can see that we can make conditional statements based on everything that we're starting to put together here. We have now used a function. We've used multiple parameters. We've used a conditional statement. We've used relational operators. Okay, we've got the Boolean, right? This is true and true. We're returning something. This is true and true in this situation. Then we're going to return something else. So we have different situations that can come back. So we need to meet those criteria, and we're starting to use that. Look, we're reusing the return instead of the print feature. There's a bunch of different things that we're doing here that's all starting to tie in. And hopefully that's starting to make sense why we do things. We're starting to build upon it, and it's starting to get a little bit more fun. So from here, we're going to go ahead and move on to lists and move on with our journey into Python. So I'll see you in the next lesson. Let's move on to lists. So let's go ahead and do our new line. And we'll call it lists. And the best way to think of lists, in my opinion, is that they have brackets. Something like this. Now, lists are data structures. They are changeable. We can reorder them. They are basically just a group of elements. Now, everything within a list is called an item. And as I mentioned, the best way to think about lists is that they have brackets. Just like a string might have quotes around it, lists will have brackets around it. Now, again, we need to remember these are changeable. We'll talk about something here in a little bit that is not changeable, which is called a tuple. Now here, let's go ahead and declare a list. We're going to say movies. And I'm just going to list out some movies that I like. And we can do a bracket, and I can say when Harry met Sally. We'll just give these as strings. I like The Hangover. And I like The Perks of Being a Wallflower. Now you can add whatever you like here. And my hangover here, by the way, I have the hangover here. My hangover on the line here is just because my notepad here is not wide enough. If I made it wider, it would actually just continue on. So don't confuse this. If I hit enter, you'll see it goes to 148. So my wrapping does not mean I went into a new line. And lastly, we'll just say The Exorcist. And we'll close the list off with a close bracket. So if I wanted to print the first movie in the list, If I wanted to print When Harry Met Sally, I come in here and I print movies and I wanted to say 1. Do we think that would print the first item in the list? Go ahead and hit save, print, and you're going to see that it actually prints The Hangover. So what am I doing here? I am calling an index, and our index actually starts with the number 0. So when we look at an index, we need to think of it as 0, 1, 2, 3. Always count starting with 0, not 1. Otherwise, you can return the wrong numbers, and this can get very confusing. Let's make sure we add a note to this. Returns the second item in the list. Okay, we're looking at the second item with the index of 1. If we printed, for example, movies, and we gave it 0, then we would see that this will return the first item in the list. Okay, we'll save that, take a look real quick. You could see that the first item is When Harry Met Sally, and that's exactly what we're getting returned, which is what we want. Now let's look at a few tricks to splicing an index or indices. We can say something like print movies. And if we printed movies 1 to 3, what would happen here? Well, what's going to happen is it's going to return the first item given. So this is going to be index number 1, which is item 2. So first index number given right until the last number given. It's not going to include the last number. We'll even say, but not include the last number. So, no, it's a lot. Let's just print it out. Take a look. So 1 to 3 will print The Hangover starting at 1, and The Perks of Being a Wallflower, which is 2, it will not print 3. Okay, so make sure you understand if you go 1 to 3, you're only going to include 2 items, not 3 items. Now, you can also do 1 to 4, which would print all of those. If you wanted to print everything from the beginning of a number, so say we wanted to print movies 1 and we wanted to go all the way to the end, we could just do something like this. We could start from a certain point in index, print The Hangover, Perks of Being a Wallflower, The Exorcist, and we're skipping When Harry Met Sally because we're not starting at 0. Okay? We could also do, in the opposite of that, movies. And remember, if we go to 1, it's not going to include 1. It's only going to include the first item here. Everything before. So When Harry Met Sally. Everything up until this point is another way to think about it. Okay? So if we wanted to print 2 items, we'd actually have to add a second or put the number 2 here, and that would include The Hangover. That's what we wanted to do. Now, another thing that we can do is if we wanted to print the very last item, we could do a movies -1. And you don't need to commit all this to memory right now, especially if you're not working with lists. But if you ever do work with lists, you need to pull specific items down from a list. This becomes very important. So it's important to know that indexes or indices exist. You start at 0 and then you move forward. And then the way that you can splice these just depends on how you call these. Now this will return last item in list. We save that, take a look. You'll see it'll return The Exorcist here. Now we can apply methods to lists, just like printing length of movies. We'll count the items in the list, right? In the list, and we'll save that. Just take a quick look. I never closed this, sorry. So you can see it tells you your mistakes, and even I make mistakes. Come in here, try it again. You can see that we have 4 items within our list. All right, so, and that is true. We have 4 items in the list. We can also add to the list. So we can use something like movies.append. We'll add to the list. And if we wanted to add the movie Jaws, we could. And if we printed movies, you'll see that this appends to the end of the list. Let's go ahead and save that. And you'll see now that Jaws is here at the end. Now, we could also insert a movie into the list. So if we did movies.insert and we wanted to put in a specific spot. So say we wanted to put it in index 2, we could say 2, and then we could give it a movie, Hustle, the movie I just watched recently and really liked. And we can come in here and print movies now. We save that. You can see that we can actually insert Hustle here into position 2 on the index. So pretty neat. Now we can also remove movies. We did movies.pop. Come in here and that will remove the last item. So if we come in here, add a print statement really quick, save that and then print this out, you'll see that Jaws is now gone. We can also specify specific spots we want to remove. So if we want to remove index 0, we could, and then this will remove the first item. Print movies, save, go ahead. And When Harry Met Sally is now gone from our list. We can also combine two lists. So if we come in here, and let's say that my wife has favorite movies, and she definitely does, and we'll just go with a couple of her favorite movies. She likes Just Go With It, and she also likes 50 First Dates. Come in here and close that off. Well, we can combine movies. Let's say we wanted to know our favorite movies. What we can do, we can combine lists, I should say. Come in here and I could say, I want to add movies plus Amber movies. And I can print our favorite movies. And then I have now combined lists. Let's go ahead and take a look at that. Hopefully I did it right. And you can see now The Hangover, Hustle, Perks of Being a Wallflower, Exorcist, Just Go With It, 50 First Dates. You could also just come in here, if you copied this, by the way, and just pasted this. You don't have to put it into a variable. You could totally do it like that. But I think storing in variables is a better practice. So I'm going to go ahead and just Control Z here. And one more thing. So we can also have what are called 2D lists. So two-dimensional lists. So let's say, for example, we have grades. And we have a list of grades, and we're going to say that inside this list, we have Bob, and his grade is an 82. And then we have Alice, and she has a 90. Okay, and then we've got Jeff. Jeff's not doing so hot. Jeff's got a 73. Okay, and let's say we wanted to pull down Bob's grade. We could make a variable, like, just call it Bob's grade. And we could set that to grades and then do something like 0, 1, like this. And what are we doing here? Well, we're saying I want to pull from the first index, okay, index 1, or 0, right? First index, 0, 1, 2. So I'm pulling from 0. And within that, I want to pull the second item, which is this, 0, 1. So we have a two-dimensional index here. And if we went ahead and printed Bob's grade, you can see now, if we save this, we get an 82. Well, that's correct. What if we screwed up Bob's grade and we wanted to fix it? Well, we could also do something like grades 0, 1, just kind of like we called, and we could just set it equal to 83. Maybe it was an 83. Okay, we come in here and we print out grades. You should see that this has changed. So let's go ahead and print this. You can see now Bob has an 83. So we can modify our 2D lists as well. So that is it for lists. Remember, lists have brackets. Lists are data structures. We can change lists. As you saw, we were able to append, pop, insert, remove. okay, we can modify many different ways. We're going to move on here in a second to what are called tuples, and tuples cannot be changed. Even though they look very much like lists, they are different. So I'll go ahead and see you over in the next lesson when we cover tuples. Okay, let's talk about tuples very quickly, and then we're going to move on. So do a new line, say tuples. And these are like lists, but they do not change. We'll say do not change, and then they get parentheses, as opposed to getting brackets. Okay, so we might want to have something that doesn't change. And when something can't change, we say that they are not mutable. M-U-T-A-B-L-E. They're not mutable. So that means that they're immutable. And tuples are immutable, meaning we can't change them. So we think of lists mutable, tuples not mutable or immutable. So if we have a tuple of grades, we can say something like grades are equal to A, B, C, this is the American grading system, D, and F. Come in here. If we did something like grades.pop, like we saw before, or grades.append, something like that, neither of these are not going to work. Or neither of these will work, I should say. Proper English. What's going to happen is they're not mutable. We can't change them. Once we have this and we store it, it does not change. So if we want something that is like a list, but we don't want it to change, it's better to use a tuple. We can set something in stone, like our grade letterings, and then we can call those when we need to. We can just say something like print grades and give it a 1 and save it, and we should get a B back. Okay, and we get a B back. So that's it. Just know the difference between tuples and lists, in that tuples do not change, but they are very similar in how they can function, and there are pros and cons to each of those. We're going to go ahead and move on to the next lesson, which is going to be looping. Okay, so let's come in here, make a new line, and we're going to call this looping. So we're going to talk about two different types of loops. The first type of loop that we're going to talk about is what's called a for loop. And for loops are start to finish of an iterate. And here's what a loop looks like, and we'll take a look. So let's go ahead and get a list. We're going to say vegetables, and you can put whatever vegetables you want in here. I'm going to go with a cucumber. I'll do some spinach, and then we'll do some cabbage as well. And now what we're going to do is we're going to come in here and we're going to write a for loop. We're going to say for x, and x could be whatever you want it to be. You could say for veggies. It could be whatever you want to call it. In this instance, I'm just going to call it x in vegetables. So for x in this list, we're going to go ahead and print out x. So what do you think this is going to do? All this is going to do is just loop through the iterates, start to finish of an iterate. So it's going to say cucumber, spinach, cabbage. Let's go ahead and give it a go, save it, print it. Cucumber, spinach, cabbage. All we did was go through a list, iterate through it until we reached the end of the list, and then it stopped. So that is a for loop. Another good example of a loop, if you want to think about it, might be trying to ping an IP address, so like a 192.168.1.1, or maybe you have 1.x. Maybe there's a whole slew of IPs that you want to ping. Maybe it's 1 through 254. Okay, if you wanted to ping all of those, you might want to do something like a for x in IP, and where IP is just equal to like a sequence. Like say IP is like a sequence of 1 to 254. And don't worry about this, I'm just logically writing this out. So if you say IPs 1 to 254 for X and IP, and then you want to do something, you might want to like ping 192.168.1.x. and then x will be 1, then 2, then 3, then 4. Okay, so you could write something like this for a ping sweeper. Again, it's a start to finish of an iterate, 1 through 254. We'll stop at 254 when the iterate is done. Now, another example of this, or another example of a loop, is what we call a while loop. We say while loops. These execute as long as true. I should probably capitalize true. So that way it makes sense that we're talking Booleans. So let's think about this situation. What about we set I equal to 1? So we've got a variable of I equal to 1. While I is less than 10, we're going to go ahead and print out I. And then we're going to say I plus equals 1. So what's going to happen? Well, while I is less than 10, so right now, I is equal to 1. 1 is less than 10. That is true. We're going to go ahead and print I, increase the value of I by 1. So the next time it loops through, it's going to be 2. And it's going to continue on until this is no longer true. So if we save this, this should print out 1 through 9 because we're not looking for 10, just 1 through 9. So we're going to say that, hit enter. 1, 2, 3, 4, 5, 6, 7, 8, 9, and it looks like the loop actually did its job. So again, we have two types of loops. All we need to know about right now is we have a start to finish of an iterate. That's a for loop. Then a while loop executes as long as true. We may see these later on as we do our project work. So keep these in mind as we go on through the course. So from here, we're going to go ahead and move on to advanced strings. So I'll see you over in the next lesson. Okay, let's take a look at some advanced strings. So if we come in here, again, we do a new line. So go ahead and enter advanced strings. And let's create a variable of my name. I'm going to say my name is Heath. Now, let's say we wanted to print my name and we wanted to grab the first letter of my name. How do you think we might do that? Well, if you're saying index of 0, you are absolutely correct. And we can say in here first letter. What about printing the last letter of my name? Well, if you say -1, you have remembered your index lessons. Great job. That's going to be the last letter. We can save this and we can go ahead and print. And if I made this a string, that would be very helpful. Go ahead and save this. You can see that we get the capital H and the lowercase h here because my name starts with an H and ends with an H. So another thing to note about strings, much like tuples, they are also immutable. You cannot change a string. We cannot modify the string. We can join strings. We could split strings, and we'll talk about that here in a second. But once I have set this variable in this string is here forever. I can always change the value of this variable, but you cannot change this string. So again, strings are immutable. Now let's go ahead and say we have a sentence. And we give that something like this is a sentence. If I can type today. And we print out sentence with something like this. What do we think that's going to look like? Let's save this, print it. You can see that we get this. What are we doing? Well, we're just grabbing this first word. However, we have the benefit of knowing what the first word is and how long it is. So we went 0, 1, 2, 3. Remember, we stopped at 4. So we grabbed the word this. Well, what if we were in a situation where we didn't know what the word was or how long the first word was? We could use something like a delimiter. So we could say print. We could do sentence dot split. And if we do a dot split, we can just do it like this. And then this is a delimiter. And a delimiter says we're going to take something and we're going to split based on that. Now, the default delimiter in Python, if we just give it a split, is a space. So we save this, come in here. This is a sentence. Now, look at it, it's in a list. We could pull the first item if we wanted to and know the first word instead of having to split it like this or pull it out like that. So we could do something like this as well. This is just a proof of concept that's a little bit fun. We go sentence, split, and we say that is equal to sentence dot split. Okay, and then we also create another variable and we call that sentence join, and we say that is equal to space. We're giving it a delimiter to join on. Actually, we're telling it what to add in between the different words that we're pulling out. So we're adding a space here. And we're going to say join sentence split like this. And if we print out sentence join, what do you think we're going to actually have happen here? I'm going to save it. Guess what? This is a sentence. So all we did was deconstruct this sentence based on the delimiter. It came out to this is a sentence, and then we joined it back together with a space. So every one of those got a space in between, and that's it. So that's just a nifty little way to show you that splitting and joining is possible. And again, this is still immutable. Even though we're messing around with the strings are immutable. So let's take a look at a few other things here. I mentioned in the beginning of the first lesson when we were talking about strings initially that we might have different ways of using single quotes and double quotes. And think about this, like what if we had a situation of quote and we wanted to say something like, he said, give me all your money. Well, with this situation, what are we going to do? What if we wanted to add quotes here and say, give me all your money? We do that because that is a quote. Well, it looks like it's kind of messed up. We're not seeing it in green. It kind of looks funny. What we can do in this situation is we can use single quotes if we wanted to. Or we could flip this around, by the way. We could use single quotes on the outside and then double quotes on the inside if we wanted to use double quotes here. And I could save this. So let's print out quote just to show you, and then we could save this. Another thing that we can do, though, is we can say something like quote, and then we can just do he said, and we can do character escaping. So we can do give me all your money like this. And now Python knows that everything within these escaped characters is ignoring this double quote here and ignoring this double quote here. So we're escaping that, and then we can print it, and hopefully we did this right. Go ahead and print. You can see now it says, he said, give me all your money in double quotes, while we also use double quotes on the outside. So we can use character escaping if we want to. Just know that we'll have to use this backslash in front of each of the characters that we want to escape. Okay, let's take a few more examples here. So if we say something like a variable of too much space, what happens in a situation where we have, like, you can just add as much space as you want in here, it doesn't really matter. We have a string with a lot of space in there. Well, we can strip this out. We can print too much space, and then we can do a dot strip. And the strip is going to take the delimiter of a space as default. And that will also strip this out. You can see there's just hello there, nothing else. So that's kind of nice. A few more items. What if we have the letter of A and we have the word of apple? Okay. Well, what if we wanted to know something like this? Let's actually go up a little bit. And let's say we wanted to know, like, print A in apple. Okay, and what is this going to return? Go ahead, and if I could type, sorry. And this is going to return something. Let's go ahead and save that. That's going to return true. So we'll just say true. Now if we print A in apple, you're going to see that this is going to return false. Save this. Why? Well, this here is a lowercase a, and that does not exist within apple. So even though we're looking for a specific letter within a word, we have to match case sensitivity in order for that to return true. So if we wanted to know if the letter A was in the word apple and we weren't concerned about case sensitivity, then what do we do in that situation? Well, this brings something up that we did a little bit early on, which is using lowercase. Remember the lowercase method. We can say print, and then we can come in here and say letter.lower. You could also do upper if you wanted to, but what we're doing is we're converting all of this to lowercase. So this is now going to be a lowercase a, and then we could say in word.lower, and we can just say this is an improved way of doing this. So if we print that out and we save this, this should come back as true. So think about when you're trying to match a word or a string or anything, and if somebody came in and you were expecting, like, I don't know, like think about school, and we're thinking about a word, maybe like Manhattan, I don't know, and somebody types in Manhattan like this. Okay, we still want to be able to accept that answer is true, even though they may have screwed up a little bit on the punctuation. Now, there could be instances where we want a capitalized letter and it has to be very specific. In that case, this kind of syntax works. But if we're looking to just accept an answer, like Manhattan for Manhattan, then we might want to consider using lowercase or uppercase in that situation, just to match those words or letters or whatever it might be. So one more thing. Let's look at what is called string formatting. So if we do something like movie, we'll pick The Hangover again. We say The Hangover. You can pick whatever movie you want here. There's a few ways that we can print this out. Remember, we concatenated early on, and we said like print. We did something like my favorite movie is space plus, you know, movie, something like that, right? Well, we can actually write this in a certain way that is a little bit easier. So there's a few things that we can do. For example, we can do my favorite movie is, add a couple brackets in here like that, and then we can add period at the end, just because we're going to close our sentence. We'll say dot format, and we'll say movie, and close that off. That's one way of doing it. Okay, if we save that, you can see my favorite movie is The Hangover. Okay, this is called using the string format method. Now, what we can do, there's another type of method we can use, is we could say print my favorite movie is %s, and we say %movie, just like this. Save that. This is using % formatting, and look, the same thing happens. I just forgot my period in there, so no big deal. Lastly, if we print out an F in the front, this is called an F string, or what's known as a string literal. We can do my favorite movie is, and then just do movie like this. Super easy. And we have moved off of using the format method and the % method into this F string or string literal. And we come in here and save this, tab up, print, and you can see my favorite movie is The Hangover. So that worked out perfectly well. You can use any of these to format, but just know that the F strings are the latest and the greatest way of doing it in Python 3. So that is it for this lesson. We're going to go ahead and move on to dictionaries. Okay, so we'll add new lines in here, and we'll say dictionaries. And we can think of these as key value pairs. And also think of these with the curly braces like this. So we've seen lists like that, and we've seen tuples. Now we can think of dictionaries with the curly braces. So let's go ahead and we're going to put some drinks. And again, I'm going to use alcoholic beverages. You do not have to do that. You can use whatever drinks and prices in here that you want, but we're going to have a key value pair. So our key is going to be the drink. So first drink I'm going to pick up is a White Russian, and the value is going to be 7. Let's say that a White Russian costs $7. If we do an old fashioned, we're going to say that this costs $10. And we'll do one more. We'll do a lemon drop, and we'll just say that this costs $8. Okay, and we can make a note here to ourselves that drink is the key, price is the value. Remember, key value pairs, key value. All right, so we've got our drinks. We can print our drinks. Save this, go ahead, print. And you can see we print out our dictionary here. Now, let's give it another example. Let's say that we have employees. And this could be a good example. So we say we have employees, and I really like the show Bob's Burgers. So I'm going to use Bob's Burgers here as an example. Let's say we have different departments. We've got the finance department. And in the finance department, we actually have a list of people. What if we've got Bob, we've got Linda, and we've got Tina, all in finance. We can also have another department. Let's have IT. So again, that's the key, and the value is going to be this list that we're putting in there. So Jean, Louise, and we'll throw Teddy in there as well. And that one, and let's do one more. We'll do HR. So HR, and we'll put in here Jimmy Jr., and we'll also put in Mort. Again, you can put whatever you want in here, and if you need to pause, if you're trying to follow line for line, word for word, you need to pause and type this out, feel free to do that. I'm going to go ahead and print out our employees just to show this. Make sure I type this all right because this is a lot of syntax. And we've got finance, IT, and HR. Looks like we did a great job. Awesome. So let's say I wanted to add a new key value pair. I could do that in a couple of different ways. We can do something like employees, and we can just say something like we want to add a legal department. All right. And in the legal department, we're going to have just one person. We'll just have Mr. Frond. He's our legal team. Okay, we'll just say adds new key value pair. Save that. Actually, let's print employees so that way we can actually verify. Save, print. And you can see legal adds Mr. Frond. So we are adding to the end of our dictionary, just like we added to the end of our list. Everything gets appended to the end unless we specify otherwise. Let's go ahead and come in here. Another way that we can do this is we can say something like employees.update, and we can say something like give it a sales department. And in the sales department, we'll have Andy, we'll have Ollie. Close that off. We're also going to have to close off our curly braces, and we'll close off our parentheses. And if you have a decent notepad, it'll show you where your items are, so that way you know you're closing things off correctly. So we've got 3 different types of syntax going on there, and it sometimes can be hard to read. So here we could say adds new key value pair as well. So just another way of doing it, we can print employees, and we'll see that Andy and Ollie should be added provided we typed everything correct, which we did. So here's sales with Andy and Ollie. Okay, one more thing. Let's say that we wanted to update something in our dictionary. We're going to go ahead and update a value. We're going to go back to drinks for this one. Let's say that inflation has happened, which it has. And with inflation, the price of a White Russian has now gone up from $7 to $8. We can do something like that, print drinks, and you should see that hopefully this has been updated to $8, which it was $7 before. Now it's $8. Perfect. We can also grab the value of that. So if we wanted to do something like print drinks.get, and then we do White Russian, we could totally do something like this and save, and hopefully it will return 8. And it does. So that is it for this lesson. We're going to go ahead and move into a new file here in the next video. So let's go ahead and save this and close this, and we'll prepare for the next video. So I'll catch you over in the next lesson. Okay, so I wanted to talk about importing. We're going to talk about importing modules. So I wanted to make a new file for this. Let's just call this mousepad importing.py or whatever you want to call it. And I'm going to do the ampersand here. And again, if you're using Windows or Mac, just make sure you create a new file for this. I'm going to go in here and I'm going to add my shebang like before. I'm going to declare bin python 3 and save this. And now we're going to go ahead and talk